Hello everyone, welcome to my channel on data analytics. In this video, we are going to learn about imputation, which is a key task in data mining. We will also go through a demo in this video for better understanding of imputation techniques. The 5 steps of KDD framework is shown here. If you do not know about this framework, I request you to pause this video and click the link shown above to know about this framework. If you already know about this framework, then let's continue. In the previous video, we have discussed the selection of data needed for your analytics using SQL. In this video, we will learn about preprocessing. In the interest of time, we will focus primarily on imputation techniques. The outline of this video is as follows. First, we discuss the various categories of missing data and how to treat them. Second, we provide the cheat sheet of various imputation techniques for handling different forms of data. Third, we describe 3 basic imputation techniques in detail with an example for each technique. Finally, we provide a demo of the imputation techniques using the real world data. Coming to the categories and treatment of missing data, the missing data within a database is broadly classified into 3 types. The first category of missing data is missing completely at random, that is MCAR. Let us look at an example. Assume there is a class containing 30 students. Now, a professor has conducted an exam to all the 30 students in Moodle. Assume that due to a network issue, Moodle has recorded the answers of only 27 students. Okay, the Moodle could not record the answers of another 3 students. In this case, the missing data of these 3 students represent missing completely at random, because among the 30 students, every student had the equal chance to miss his data. Okay, so in this case, we call the missing data as missing completely at random. Now, the second category of missing data is missing at random. An example of this category is as follows. Assume in a class containing 30 students. Now, the professor conducted the exam for all the students. If one student has skipped attending the exam while others have written the exam, then the missing answers of the student who skipped the exam is called MAR, that is missing at random. The reason why this missing data is called missing at random is very simple. In the earlier case, every losing the data of every student was equally distributed. But in this case, a student not attending the exam is completely dependent on himself. So the probability is not equal to all. In that's the reason why we call the missing data as MAR, that is missing at random. The final category of missing data is called missing not at random, MNAR. So in this case, once a professor is conducting an exam and the student was absent from it, okay, and the reason for his absence is not because of his decisions, but instead it is dependent on the professor's study material. Then we call the missing data as MNAR, that is missing not at random, means there is a conditional probability that is kicking in for missing the data. So if there is a kind of conditional probability that exists in missing out the data, then we call such data as missing not at random, because there was a condition. We may not know, but there was some condition that kicked in to lose the data. Okay, that's a thing you have to keep in mind. Okay, so given these three forms of missing data, the complexity in dealing with this data varies from left to right. That is, handling MCAR data is very easy. Okay, but handling the missing data at random, that is MAR, is relatively difficult, and handling the MNAR data is much difficult. So let us see at the solutions. If you have MCR data, what we do is we simply remove the rows or columns. Very simple. If our data missing in our data, if the missing data falls in MAR category, what we do is we do imputation techniques. And if the missing data within our database falls in MNAR category, then we have to do sanitizer, sanitization. So these are the things. So MCAR, MAR, and MNAR. So these are the three categories of missing data. Now let us focus only on imputation. That is, if your data contains MAR. So there are several imputation techniques to handle MAR. The cheat sheet is shown here. Okay. So in particular, if your data is numerical, then we perform single imputation or multiple imputation techniques. Okay. If your data is categorical, then we do frequent category imputation and addressing the missing category. So we do various ways depending upon your data set. So in this video, we focus on data containing numerical values and then imputation. So when we consider these three things, data with numerical values, and we are going to perform imputation, then three popular techniques are hard-deck imputation, means substitution, and kNN-imputation. We are now going to look at these three imputation techniques. The first technique is hard-deck imputation. It is the easiest technique. So what we do is, if we have the data set, what we do is we simply classify the data into donor units and recipient units. Donor unit means the rows that contain no missing data. Recipient unit means rows with missing data. Now, for each recipient unit, we choose the rows from donor units and try to predict the missing data. Let us see an example. Okay. So here we have the small data set with 6 rows. So the data set contains unit, age of the person, gender, and pregnancy. That is whether a person is pregnant or not. So we have this data. In this data, we have 3 rows with complete information and 3 rows with incomplete information. In the hard deck imputation, first what we do is we identify the donors. That is cells, rows with complete information. Once we identify the donors, next we identify the recipients. That is rows which contain missing data. Now, in the third step, for each recipient unit, we choose a donor randomly, let us say unit 1, and then we fill the donor's value here. So if we choose the donor unit as unit 1, then we simply fill its male value here. Similarly, okay, let us try to fill the missing data for unit 4. Assume that the donor is unit 5. Please pause this video and try to answer what is the age of unit 4 if the donor is unit 5. If your value you guessed is 22, then it is the right answer because 22 is the value of unit 5 which we are going to keep it here. Similarly, please guess the values for unit 6 if the chosen donor is unit 2. Please pause this video so you can answer it. Now, if you have guessed the gender is female and pregnancy is 1, then your answer is correct. Otherwise, it is wrong. So, this is how we perform hard deck imputation. Simply choose the choose a random row from the donors and try to fill in the values. So this is the basic hard deck imputation technique which can later be revised. Okay, but this is the basic one. Now let us look at another imputation technique which is mean, median or mode substitution. This technique is very popular to handle numerical data which is generally sequential like time series data and all. Then this approach is very useful. Let us look at an application or example. Assume we are collecting the daily weather temperatures. Okay, so these are the day wise temperatures we have recorded. Unfortunately, we were unable to record for a particular day. Okay. So, we have to predict the missing value here. To do this, what we first do in the means substitution method is we gather the data that is available for us. Okay. Then in the next step, we sum up the values. In the final step, we calculate the mean value and replace the missing value with the mean value. So this is called mean substitution. If we use median of the available values, we call it median substitution strategy. Similarly, if we use mode, we call it mode substitution strategy to fill up the missing data. In this mean, median, mode substitution, we are using the entire data that is available to us. Sometimes it may be it may be useful to use only the data that is very close to the missing data. For example, assume the temperature of this day primarily depends upon the before day and the later day. In these such cases, if you want to use only the portion of the data to predict the missing value, then we call it k nearest neighbor. In the k nearest neighbor solution, what we do is we only choose the data from the nearby locations. For example, for the missing data, the nearby locations are 16 and 19. So we take only this data, we calculate the mean, and we replace the value. If we do it, then this process of imputation is called kNN-imputation. I hope you have learned three basic imputation techniques. We will now look at the demonstration. For demonstration purposes, we are going to use the air pollution data generated by a sensor in the AEROS system. You can find the data in my GitHub repository. So please come to my GitHub page and check the repository Introduction to Big Data. In this repository, if you visit the class 3, then you can find the dataset that I have used for the experimentation and also the notebook file that I am going to use for this experimentation. If you click, you can find the notebook file here. Okay, so now let us do this notebook. So please ensure that the time series data is already available in your virtual machine. You can do this either by mounting your Google Cloud Drive or uploading the CSV file here by pressing this button. Now, in the first step, what we are going to do is using the pandas data frame, we are going to read this file. Once we have done it, what we are going to do is we are going to check whether this value exists in the dataset or not. This value exists means there is NaN value in the time series data, because this is the value the SORAMAME system uses to represent missing data. Now, what we are going to do is, if we find any cell containing 9999, we are going to put NaN value in those cells. Once we kept it, now we are going to check how many cells in the time series data are containing NaN values. So we found out that in the given time series data, there are 101 cells with NaN values. So now what we are going to do is, we are going to draw the time series data in a plot. For ease of visualization, what we are doing is, we are drawing only first 500 points that exist in the time series. So if we draw the first 500 points, we can see that there is missing data at this point, at this point, and at this point. So we can see the missing points. Now, using the sklearn, we are going to implement mean imputation. So you can see here, we are going to perform the mean imputation, and we are going to predict the values. Once we perform mean imputation, we are plotting the mean imputed time series data. So here we have received the time series data with mean imputed values. You can see now we have predicted the time series for the missing values. For brevity, what we can do is, we can overlay the actual data and the imputed time series data. So you can see here, the actual data is represented with thick black line, while the imputed data is represented with the red line. So as you can see here, okay, where there is missing, using mean imputation, we have predicted the missing value. So this is how mean imputation works. If you liked our work, please press the like button, share it with your friends, and subscribe to our channel for getting latest updates. If you want to access the material we used in this video, please check the GitHub link provided below. For more information, please check the playlist. Thank you.